instead of you using this like truffle and ganache, why not use that?
No,
now waiting to do.
You know if you change, go at that now. So you get. Although
Yeah,
now
I know.
that makes sense because the console sheet, but anyhow, now truffle most people use start safe. Me say now truffle I first use before and know say go at that. Make a check.
Don't await anything, just run the stuff like that.
I think now it's better, sir. Yeah. Oh, I'm okay with that. Are we live?
Yeah, we are live.
Okay. Welcome to Blog Games live session. Today we're going to be talking about how to build a DApp. We're going to, at the end of the day, this is what we're going to build. This is like a basic DApp where a user can send tokens from their wallet to another user's wallet. Okay, so let's start from the beginning. So Ethereum development stack and quick start. So Ethereum development frameworks are SDKs or software development kits that make smart contract development, testing, deployment, and management easier for blockchain developers. So basically they abstract all the low level stuff of like interacting with nodes and stuff like that. So we're going to compare 3 of the most popular Ethereum software development frameworks at the moment. So number 1 on our list is Truffle. So Truffle is based on JavaScript and it's been around for quite a while now. So it has like a large user base and they have like a larger amount of tutorials available. It's pretty popular. It's okay. So it handles smart contract compilation, linking, and deployment. The framework supports scripting and is scalable. It provides network management for deploying to multiple networks, so you can manage multiple networks on a single project. It has features for package management. Okay, so you can abstract package management without using npm. It has an interactive console for direct contract communication. It supports migrations and tracks states on networks, basically to track your current state on the network, which contracts you've deployed, and the state of those contracts on the network, so you can conserve gas fees and monitor your state on the network. And there's a large amount of resources and tutorials available for learning. Okay, so next one we have is Hardhat. Hardhat is one of another very popular framework too for developing Web3 components and Web3 applications, basically. So it's also based on JavaScript. It has similar features with Truffle, which allows you to build, compile, test smart contracts. Okay, so it focuses on Solidity debugging, featuring stack traces, extensive stack traces. So
Manuel,
yeah.
please can you slow down a bit?
Okay. So Hardhat focuses on Solidity debugging. It helps in watching stack traces, basically. So they have very informative stack traces and error messages. Then they also have like a customizable plugin workflow, basically. So you can like choose exactly what you want in your project. So the other framework we have is Brownie. Okay, so Brownie is built on Python, and it also supports Solidity and Viper, basically. So it also handles compilation, debugging, and deployment. So most of these frameworks offer similar features. It's left to your personal choice and like your discretion to choose the one you're most familiar with. So we also have some others. I'm sure most of you are familiar with Remix. So Remix is a browser-based IDE that allows you to compile and to deploy right in your browser, basically. Another example is Embark.js. Embark.js is another development framework too that also handles compilation and deployment. On top of that, Embark.js also allows us to create our dApps or our user front end right within that framework too. So Embark.js supports creating user UIs. Then OpenZeppelin recently released their own SDK for creating contracts and deployment, basically. So those are some other frameworks that we have on the market. So today we're going to be creating a complete DAO or a basic DApp really that makes use of Solidity, Truffle, and Web3.js to communicate with the application. Okay, so the idea is to create like a to-do list with a twist. So this will be like a to-do list on the blockchain where you get others to do your work for you. Of course, you have to pay them with a token or you have to like enumerate their efforts. So we'll create this app as the owner of the contract, and individuals performing tasks will be referred to as doers. So as an owner, you'll be able to create a task, accept a completed task, reject a completed task, reward the doer for successful review of a completed task, basically. And as a doer, you'll be able to start a task, finish a task, withdraw old rewards for successful reviews of completed tasks. Okay, so let's get started. First thing first will be to install Truffle globally. I've already done that, so I won't be doing that now. So, okay. So for those that are curious, I'm using Windows subsystem for Linux, basically, for my coding environment, because that's easier, basically, to handle binaries and distributions. So first thing we're going to do is truffle init, which is to create a new truffle project, basically.
Emmanuel,
Yeah?
sorry to interrupt. They still think that you're too fast.
Sorry. I'll try to take it slower. Okay, so we're creating the project now. So we've created our project. If we go to, okay, let me run code. Okay, so this is a newly created project. Front end is another folder I had created previously, basically that holds like our user UI. I'll explain that in a moment. So this is our truffle project, basically. So we can go ahead and create a new contract. Okay, truffle create contract to do coin. So our newly created contract with some scaffolding content, basically. So because I want to use external libraries, I'm going to also create a new npm project in this folder. Okay, we're going to make use of OpenZeppelin's ERC20 contract, basically, to create our token for sharing, or for payment, rather. So our package.json has been created. So I'm going to install OpenZeppelin. So part of, if you can look at the project structure, we have the contracts. Okay, so that stores all our Solidity contracts. Migrations is a default contract created by Truffle to manage our state on the network. We have migrations. Migrations basically handles deployment. So this is where we write our code to deploy contracts, basically. Then we have tests for writing tests, basically. We'll write a few unit tests or just a single unit test to show how that works.
Yeah, Emmanuel.
Yeah. Can you hear me? Okay, okay. So we are waiting for OpenZeppelin contract to install. When that installs, we're going to have access to all of OpenZeppelin's contracts. I want to make use of the ERC20 contract to build our token for sharing. So that will be to do coin. Then we'll have another Solidity file, basically that's TaskMaster, or like you can think of it like a DAO for governance, something like that, basically. So that would be the actual smart contract that our application would interface with. So let me go ahead and create another shell at this one.
So basically, we have two smart contract projects open, right?
Is it?
I said basically we have two projects running simultaneously, right?
If you're talking about number of contracts, we have the migration also on the to coin. Let's just open another terminal. Okay, so OpenZeppelin has finished installing. Is that okay?
Yeah, that's fine.
Okay. So we can go to node models basically to see what we installed. So this is what we want basically, which is a contract basically provided by OpenZeppelin. It contains all the ERC20 standards, so we don't have to implement them ourselves. Okay. So I'm basically just going to import this.
Okay, sorry. So basically, what you are telling us is that OpenZeppelin has like already made code
Yes.
for us to implement, right?
For the ERC20 token, yeah.
Okay, so it saved us code, lines of code, tons of
Exactly.
code. Okay, yeah, I think we all get that now.
Okay. Yeah. So after we import this, we can now use ERC20. So the ERC20 token has a constructor of its own that takes in a name and a symbol basically. So we're also going to initiate that basically when we're calling this one's constructor, and the variables are going to pass to do coin and TCN. So the next function I'm going to call is mint, which is provided by the ERC20 contract that we're inheriting from. And so I'm going to call mint to give us new tokens.
Oh, sorry. Can I say something?
Yeah.
The to do coin. Okay, basically, you are basically inheriting from the ERC20 token module, right?
Yeah.
Okay, and the mint is coming from there, not ours, right?
Is it?
I said the mint is a function that is written in the ERC20 token, right?
Yeah, exactly.
Okay, yeah. I think we are fine. Let's go.
Okay. Trying to locate my shell. Yeah. So we've got that. So let's run truffle compile, check whether we have any errors.
So what do we use the truffle compile to do?
So truffle compile is used basically to compile our code. So it abstracts basically, it's going to create our RB and our bytecode. Okay.
Okay, yeah.
What just happened? Code then. Let's talk about an error resolving this. Okay, because of Windows here. I think if I move this. Okay, so that was the error. We had an issue with the backslash Windows error. So we've compiled our contract, but we've not deployed it, obviously. So we have the IB and the bytecode basically in the build folder. That's where Truffle stores all of our compiles and builds basically. So we can actually go ahead to deploy just this.
Yeah, sorry. You said after compilation, we get some some ABI
Bytecode.
and bytecode. Yeah. So can you please explain to us what is the ABI? I
Okay.
pretty much can say this is the first time I'm hearing ABI.
So ABI is like an interface or application interface. So like it tells other programs what functions our contract defines and like how to call them, the parameters it accepts, and basically just how the contract works basically. So it's like an API and tells like external applications how to interact with our contract. So bytecode stores the actual like compiled code or like compiled bytecode of our contract.
Okay, it's just like the normal way our application program interface works, our API for the backend,
Exactly.
right?
Exactly.
Okay.
Just that, like we're not calling a live server, but like we're telling them you could think of it like a documentation, somewhat like a documentation. So we're telling you how to call our functions basically on the contract and interact with the contract basically.
Okay, I think we are getting a clearer picture of what ABI is then.
Thank you. So next thing would be to create a migration. Deploy to do coin. Okay, so weird name. Let me change this to So this is actually an ERC20 token, basically. We have actually created an ERC20 token. So by inheriting from OpenZeppelin, we saved ourselves from writing tons of code, okay? So we give our message sender our initial caller, one, I think, yeah, 1, 2, 3, 4. I think let's increase this because we're going to have decimals. So I think that's okay. I'm renaming this migration to something we can all relate to, which is Ethereum. So basically what Truffle does is like it runs a migration and tracks that it has run that migration. So similar to how you have migrations in your database. So it tracks state. So you can like make changes to the state on the network without like having to go through all the process of maybe deploying again. So that's how Truffle works. So for example, maybe you want to change your contract's address, like maybe it's linked to another contract, and you want to change that contract's address. You wouldn't have to like redeploy. Truffle will be able to like retrieve that the initially deployed contract's address and then edit that. Okay.
Okay, yeah.
So I have Ganache running in the background basically. Ganache is like a development blockchain basically. So we can use it to like debug and to test our application. Okay.
Okay, a local blockchain, right?
Exactly. So file renaming is going on. So if we look in the initial migration, we can see like a typical Truffle migration basic. So we have a deployment basically. So we're deploying the migrations contract. That's just what this is doing. So we're going to do something similar. We're going to deploy our own contract. So this is going, artifacts is going to look in the build folder for a file with the name to do coin, basically. So to do each JSON file in the build folder is going to track a single contract. So if you had like multiple contracts in a single Solidity file, it's going to compile each and put them in a single JSON file. So that's how Truffle works. So this is accessing this to do file basically. We're going to deploy it. And if we notice, our constructor doesn't take any parameters, so we don't need to pass any parameters in our deployment stage. So this is going to go ahead and run Truffle migrate. which basically runs Truffle's migrations. Okay, interesting to note, I've not yet set up my networks. So I'm going to set up my network to connect to Ganache. We're going to edit the Truffle config file. Okay.
Yeah, so what does the truffle config file do for us, please?
Okay, Truffle config file like stores our settings for our project basically. So if you want to like save your mnemonic or like choose how many blocks you want mined or like set up a development network basically. So it just stores our settings and environment variables. That's what truffle config.js does for us. So each truffle project is going to have a truffle config.js file that stores the settings for that project.
So
Okay.
I think I want to start now.
So we have like boilerplate code here. I'm going to implement this. Okay, so Ganache's network ID 7545. I'm going to change this. And we should be good to go. So truffle migrate. And we pass in network parameter development, which is what we defined here. Okay, so let that run. So Truffle is going to basically create a new transaction that deploys our contract on Ganache. If we check Ganache, we should see a new transaction.
I guess it's still loading.
Yeah. Okay, so we've gotten our network ID, log gas limit, and stuff like that. So next thing Chuff is going to do is deploy the first contract file, which is migrations, the initial file given to us by Chuff.
Okay.
Then now it's going to run our migrations, our second migration, which is going to deploy our to-do coin. So you can see that we're spending gas, though it's test ether. We're burning ether basically on our transaction. So each transaction call is going to take ether, basically.
Okay, because we are actually making use of Ethereum blockchain, right?
Exactly. So we're going to pay
So,
network fees in the local currency of the blockchain, which is Ether in this case. So according to
okay.
Truffle, our deployment was successful. Okay. So we could check transactions. Occasionally, Ganache has some issues with refreshing. So this is 832. Okay, I think this is accurate.
Yeah.
Okay. So go to transactions, contract creation. So this should be our to-do coin because that was deployed secondly. And this should be our migrations of so far. Okay. So interestingly, if we try to run truffle migrate a second time, what we're going to get is truffle is going to tell us that our state on the network is already up to date. So there's no need to like run another set of transactions. So that's the whole idea of truffle migrations, to track your state on the network and make sure like everything's up to date, as we can see.
Okay. Yeah. I think we are following, and but to do us better, we can like just slow down a little bit. Some of us are complaining, they are saying you're speaking like someone from outside the country, so you should try to
Oh,
like slow down.
sorry. Okay. So next thing is we want to check our token, whether our token is actually working. So we can like interact with it like a normal token.
Yeah,
I'm
sorry,
going,
we forgot to ask a question. How did you install Ganache? Is he an npm module
no,
or?
no, no. It's a typical like application. So if it was Windows, you'd get like an MSI installer and you just install that. So like an application, if it's Linux, you use like sudo apps to get that. So this is Ganache UI. There's Ganache command line interface. So I prefer Ganache UI. So you can just get it online. I'll send the link for that, I guess, in the resources.
Okay.
Okay. So we have MetaMask. And I want to check basically that our token deployed successfully. So this is another token previously. So let me import the account. Okay, the account has already been imported. To see, okay, this is it. So 2C, 2DB88. Okay, so because our token, we have to like import it basically. So let me get the ID or the hash basically, the address. I'm going to import that. And it autofills basically because it picked it up on the network. Okay.
Yeah, we'll follow.
Okay. So interestingly, we didn't set like a from account basically in our deployment. So I'm thinking
Like the deployer, right?
exactly.
Okay. No, sorry, click on the token. Like, let's see. Is it 0.000?
I think that's what happened. So basically, I think let me check the number of decimals that the ERC20 token defines initially.
Way, I think it's
18.
yes. So I
You
don't
have to
know
increase
what
it. Yeah. Let me check that.
exactly.
Mm,
I think we basically did 10 times 9. I don't know, which is 9,
yeah.
which is very.
Okay, so we
So
have
we used
18 here. Yeah.
oh,
So we
yeah,
have to increase our initial deployment. So I'm going to increase this to 10 times 9 times 10 times 18. Raised to the power of
and
18 rather. Okay. So what this does, this handles the decimal part, and then this would be like the actual whole number. So we'd have about 1 billion tokens in circulation initially. Okay.
so basically what you're telling us is like our total distribution token will be the 10 raised to power 9.
Exactly. While the 10 raised to the power of 18 handles the decimal part. So Solidity does not handle decimal parts or doesn't have like a floating type data type basically. So that's why we have to track decimals ourselves.
Okay.
Okay. So because of this, we're going to have to reset all our migrations and redeploy basically. So
Yeah, sorry, just a question. Sorry, continue.
yeah.
Resetting of migration, does our address changes? Like, does it change our address?
Exactly. Because we did not like support upgradability in this contract, so we're basically redeploying fresh. So there's no way to change our the old contract's address on each end. So we have to redeploy a new contract. And as you'll see shortly, we'd have a totally different address.
So basically, my first contract is outdated or a waste.
Yeah, exactly.
Okay, yeah.
So we can like look into upgradability later on. So that's like an idea of like deploying your contract in such a way that you can change like the back end of it without like having to change the initial address you're interacting with.
Hmm, okay.
Okay, so I think this will be the new address. Hmm. Okay, let me try that again. Let me try moving this one. It'll be conflicting.
So I'm sorry, what is the symbol of our token? The token we just deployed.
Okay, it's still the same thing. So this is the symbol and this is the name. So the name is
Okay, okay.
Bitcoin and token, the symbol is TCN. So if we check the ERC20 constructor, that's what it takes. So
Okay.
that's name and symbol. So our deployment went successfully. Contract address is 07B8E. Okay. So as you can see now, we have a new balance, which is, should be 1 billion as we defined it. Okay. So next thing would be to like create like an application that we can use to moderate our like token basically. So we're going to create another Solidity file or contract that we can finally call to like pay people for tax and stuff like that. So in this particular tutorial, we're not going to go as in depth as maybe like creating tax and allowing users to submit the applications and like revoking and all of that. We're just going to create the basic functionality of allowing user to pay for his task. Okay. So
Okay, not to like interact with our. Okay, yeah, I guess.
exactly. So message or sender, we're going to create a new contract. Shuffle, create contracts. I can call it TaskMaster. Okay, so a new file.
Okay, so basically
Okay.
that is a way of generating new file instead of creating it manually.
Manually, exactly. I could have gone ahead and still done
Okay, that's fine.
whatever really, it doesn't matter. It's just an abstraction, makes things faster. I think we should change this versioning system so we target at 0.8 just to be sure. So we don't suffer any breaking changes. Yeah. So our TaskMaster basically. So TaskMaster is going to have to call ERC20's file. Okay, like it's going to have to call our token basically and be giving out what do you call it, to be like administrating basically. So we're going to give him import the other token file, which is to do coin. So we can basically create like an interface to interact with it. Okay. Yeah. So as a constructor, we're going to take the address of to do coin. So we can instantiate that. Basically, what we're doing is creating an interface. So these are like smart contracts interact with themselves. There are two ways for smart contracts to call themselves. There's an EVM call and a delegate call. So this is just an EVM call or normal message call. So in this call, the context changes when we call a different smart contract. So message or sender, if an end user would call TaskMaster, okay, when TaskMaster calls ERC20 token or to do coin, the message or sender is going to change to TaskMaster. Okay. So this is address to do coin address. We're going to take that in. So to do coin interface is going to equal to do coin. To coin address. Do you have any questions as of now before we go forward?
No, I think I'm following. Okay. Maybe a question might need. So how do I get this address? How do I get the address this
Of the
is
to
to
do
the
coin address, exactly. Okay, so that address is going to be the exact same address we use to import to do coin into our MetaMask wallet. Okay, so that's just the contract address of to do coin.
So it's basically pulling the wallet provided, like the address provided on the listing.
Exactly. So let's say we want to reward doer. We can have a function like that will take an address and basically reward him. Okay, so address recipient or doer and an amount. Okay, that will be UN. Okay, so basically what it's going to do is like the owner of TaskMaster contract is going to be able to reward the doer with this contract. This abstracts the logic of like transferring tokens from one place to another. So we also want to make TaskMaster ownable. The idea is that like only a single person should be able to own it. So don't need to like import that. We can just create basic variable to track who deployed the contract.
Okay.
Okay.
Yeah.
Then we can create a modifier only owner. Okay. Oh, we don't need to pass that in. We can have like require is equal to owner. So we can say only owner can call this function. Then we revert control back to the initial function. So what basically we're doing here is that we're going to check that the person that called this function is the owner. Else we're going to raise an error that only owner can call this function. Okay?
Yeah, I get you. So what's the misfitness of the underscore put now?
Okay, so this returns control or returns like execution back to the original function that we added this modifier to. So modifiers, depending on where you like add this semicolon, this returns like active control back to the function that called the modifier. So when we add the modifier to a function, we're basically calling it, and we have to return the execution back to the function that called us. So that's what this does.
Okay, so it's just like after the modifier codes run, next, like back to the code that calls the functions that call the modifier, sorry.
Exactly. So I'm going to add that to reward doer, basically. So only owner can reward doer. So only the owner of this whole DAO or like application or company can reward the doer. You can think of it like that. So to do coin dot transfer. Basically now we can now like interact with to do coin. Okay. So once again, I have to go to the contract we inherited to show you what's going on. So we have a function already, transfer. Okay. So this takes the address you should transfer to and the amount, and basically just sends that. Okay. So we're going to transfer to doer. I'm going to transfer an amount. That's all. So after checking that it's only the owner that can call this, we're going to transfer doer a set amount of to-do tokens. Okay. Interestingly, if we what is going to happen when we call this is that the message just sent that is going to become taskmaster's contract address. Okay. So when we're deploying to do coin, we're going to make it that the initial message of sender is going to be taskmaster's address. I'll show you how we do that in the next deployment. So basically, we're going to have to redeploy to do coin. I think this is okay. Then you can add a function just to test that everything is okay. Thing random number.
So basically,
Is it?
Only okay.
Okay, so interesting to note, I'm not using any like comments or stuff like that. Just
No,
keep
continue
it.
to ask.
Okay. I'm not adding comments or like not spec because I'm trying to keep it easy to follow what's going on. But if we were to like create like a proper project for like commercial use, we'd have to like add comments that describe exactly what's going on. So we have like an author and like descriptions. Okay. So I think this is okay. We can go ahead and
what does the ping function do for us?
Okay, so this is purely for testing purposes. I want to illustrate how to test without like going into too much about like transactions and like so. We're going to use that when we're testing, basically.
Okay.
So we're compiling the tokens again, basically. Okay, I thought I'd also. Interesting. Okay. Okay. No visibility. So first of all, our first error is that we specified the visibility for our constructor, which is ignored by Solidity basically as of new standard. So there's no need for that. Second one is we didn't specify visibility for this, so we're going to fix that. So this is public. Anybody can call it. Okay. So basically what is going on here is that Solidity is warning us basically that we can reduce the visibility and mutability of this function to pure because we're not editing any state variables. So I think we can also do that. So when we recompile, basically what Chop is going to do is check whether there are any file changes, okay? And when it checks that, it's going to now recompile. Okay, so I said the Solidity compiler is warning us that our function ping does not change any state variable. So it'd be wiser to mark it as a pure function, basically. So I just changed that now and I'm recompiling. So when we're recompiling an existing code base, what Truff is going to do is going to check for code changes. Then if it sees code changes, it's going to recompile that contract. So if you notice, it didn't recompile to do coin because there weren't any changes.
Okay. And if it doesn't, it won't compile, right?
Sorry?
If it doesn't see any changes in all our
Exactly. Exactly. It will just tell you that state is up to date. I think that's the message. So we have our new artifact basically, TaskMaster, which has the ABI, the bytecode, deployed bytecode, okay? Next thing will be to rewrite our deployment file basically. So firstly, we'd want to get I think we call it TaskMaster, yeah. And like I said, it's just going to look in the build folder for a file called TaskMaster. Okay. So first thing we're going to do, because these are basically like promise functions, basically, so they don't execute immediately, we're going to await the deployment of TaskMaster. Okay. And if
So we can
check,
basically await without async, or there is an
okay, yeah, we have to change this to async.
Okay.
TaskMaster. So the constructor takes in an address to do coin address. Okay, I think we're not going to pass this as a constructor variable. We're going to create a new function that we can use to set to do coin address. Yeah.
Yeah, so since we are not passing that, then are we going to remove the,
exactly?
No,
okay.
like are we going to remove the line 18? Because
yeah, thanks.
Okay.
Okay.
So basically, so all on our recompiling, all this code, sorry, on our deploying, all this code will run just to like provide our address and the likes, right?
Exactly. So all the code in the migrations are going to run. Especially
okay.
if we tell Truffle to reset our migrations, all the code is going to rerun. But if we don't try to restart, it's only going to run the new migrations that have not been tracked or run before.
Okay.
So we have TaskMaster basically. So we're going to deploy to do coin with TaskMaster's address. That's the idea. Okay, so in that case too, we're also going to change to do coin. So it won't be message or sender, it will take in an address, which will be TaskMaster's address. Okay. So basically, we're just going to reward TaskMaster with a couple of tokens. That's just the idea. So next thing will be to write the actual code. So I'll wait deployment of TaskMaster. After that, pass in TaskMaster's address. I believe that's what it's called, as the next parameter. Okay. So we're going to pass in the address of TaskMaster after it has been deployed. So next thing, first we're going to recompile because we made some changes. Okay. No visibility attached. That's on the TaskMaster, yeah. So public. Okay, I think I can start taking questions because I don't think we'd have enough time to like get to the UI today. So I'll like put that on the GitHub repository. So next thing we'll do is to write tests after compiling this.
Yeah, I was about saying that too because time is not on our side.
Yeah.
Okay. So we're basically going to write tests. What do we need that for? Just to test if our code is working.
Exactly. So
Oh.
deploy is another alias for migrate, by the way. So testing basically, we're just going to make sure that the functionalities as we expect. So no unexpected changes or stuff like the unexpected behavior. So just typical test-driven deployment. Okay. So as if you notice now, it told us network is up to date because our migrations have already run. So we're going to have to tell it to rerun all of our migrations because we changed the source file.
Okay.
So migrate reset. So this I've done deploy reset. Same thing, it's an alias. So migration run. Okay. So I made this a function around my parts. So if you notice, we just basically sent the wrong value, so we're going to have to remigrate. All of this is costing gas out. So when you're actually like running on a real, this is the reason why we need testnet. So when you're running on a real environment, you don't want to be like spending money on like bugs and stuff because like gas actually costs money. So that's why we run it on a testnet and debug.
All this is just like we are like creating a transaction, right?
Exactly.
On the blockchain, and which will cost us a gas fee.
Exactly. Okay. So we basically redeployed, and if you go to transactions, we can see what we created. So there was contract creation, migration, then contract creation, TaskMaster, then contract creation to do coin. Okay. So that being done, I think we can get to writing test.
Okay.
So that's in the test folder basically. So just test TaskMaster. It's going to be unit test. We're going to write it in Solidity actually. So this expected us write. I want us to write it in Solidity because it's like unit test. So you can write your test in either Solidity or JavaScript.
Oh, That's
So there are a couple of things we need to import. Get them here. So documentation is easily available if like you missed anything. I want to get what we're going to import at the top. So Truffle like provides us
would
this.
love if you can. Okay, yeah, would love if you can provide us the docs you just mentioned now, so that I would read up on that.
Okay. Yeah. So this is what I want basically. The imports are going to be making. So it's still a Solidity file. So we're going to have to initialize Pragma. Okay. So asset basically like a typical like asset library allows us to check whether values are equal or not. Deployed addresses allows us to get like the address of a contract that was deployed. So we can use it to retrieve a contract's address that was deployed on the network. So next thing we're going to get our contract. So that's TaskMaster. So we want to check the ping endpoint basically. So first thing we're going to do is create like a contract called like test TaskMaster. Then we're going to have to name each function with test. So each function that is going to run the test has to start with test. Okay. So contract test TaskMaster. Test ping. Yes, you can call it that. So if you look at this, none of our functions taking a parameter, and they don't have any modifiers or view modifiers. So that's okay, since they're just tests basically.
Okay.
So we're going to instantiate a new interface basically of our TaskMaster. So TaskMaster.
Yeah, must we name it the exact variable we named it in the contract?
So this isn't necessary to be the like exact same name, but then in this case, I'm creating an interface or like a new data type. So yeah, this is necessary, but this isn't necessary. So you could have called it TaskMaster contract or whatever. Okay. Another
Yeah.
area. So we're going to use deployed address because to retrieve TaskMaster's deployed address. Okay, I think that's how it works. Exactly. So basically, this is typically similar to what we did in the TaskMaster contract, where we instantiated the new interface of to do coin. Basically, so we have this data type or like an interface, and we now pass it the address of the contract on the address. So that's the same thing we're doing here. We're going to get the address of the file and then of the contract and then pass it into TaskMaster to deploy it or to like interact with it. So deployed address is going to get the address of TaskMaster on this network. Okay. So we can now like call TaskMaster's functions, like as if we were like interacting with it on the final end. So as you can see here, we can like call ping endpoint or something of that nature. So TaskMaster expected, we'd expect the variable of passing in would be 10. So I set equal and variable. Okay, let's keep things dry. Okay, and okay, so we're going to ensure that the ping endpoint returns the same value that was passed to it. That's just what we're doing. So an asset, we're just asset equal rather.
Okay, just to be certain that what we are getting as a response
From the ping
is the
instance.
same.
Exactly.
Okay.
So
Okay.
just like we defined it, whatever we get, we're going to return it back. So that's what we're testing for.
Uh,
That's the behavior we're testing for. So we can actually go ahead and run this thing.
okay. Yeah.
So it automatically uses your development environment. We didn't specify an environment to use. So next time, just to be concise, we most likely going to pass like the development flag, a network flag rather of development. So it's running our test now.
Okay, so basically, we didn't specify any environment. It will automatically pick the development environment.
Exactly.
Okay. Okay, I think we got that now.
So this has been like more of a practical class. Eventually, we should have gotten to building this. So this is the endpoint of this whole program, of this project actually. So you could send to-do tokens to somebody that's done work for you. Building on this with like add like maybe event logs and like the ability to retrieve next tasks and stuff like that. So I'm sure we'll build on this like in future classes.
Yeah, maybe from other live section. And I believe while creating this interface, we would get to work on the ABIs, right?
Yeah, exactly. The RB files, yeah. So we'll also like work with Web3.js too.
Web3.js, okay. Yeah. Probably there will be another video to complement of this live section.
Yeah. So do I have any questions?
Yeah, there are a lot of questions, but not really much.
Okay.
Okay. First of all, we are very, very sorry for will I say it's network issue or anything or something? Some people also complain of you being fast. Yeah, very sorry about that. Please bear with us.
Yeah, well, sorry.
Yeah. So yeah. So I think the first question goes. Okay. Someone said we should share the link. Obviously, we are going to send the link to the resource channel. Yeah. Someone said, how do I install my own truffle globally?
So
I
I'm
think
going to eventually send like a GitHub repo basically. I have like all of these commands. So the command for installing truffle globally would be like npm install global truffle. Okay. It's just like a normal JavaScript package.
Okay. And so any question based on installation, you guys will find it in the GitHub repo and it will be sent to the resource channel. Okay, someone was saying where did front end comes from?
Okay, so the front end is like totally separate. Okay, so we have like a total different library. In my case, I use Web3.js, there's Ethers.js. So you could think of it like a backend and a front end of like a split application, basically. So the backend will be like the smart contract part. We deploy that on Ganache or like Ringvi. Then we have like a front end that would most likely run on maybe like Node or like React, basically, that would interact with that contract and like call the API of that contract using the RB file.
Okay. So basically, our smart contract is like sorry.
Yeah, I think you broke up there.
Yeah, I said basically our backend code is just like our blockchain, our smart contract code is just like a backend code for blockchain, right?
Yep.
Okay. Yeah. Okay. So someone said, how do I get to that interface where he's doing? I guess he's talking about the OpenZeppelin interface you made use.
Okay, so that's a package, another JavaScript package. You can install it. It's maintained by OpenZeppelin. So they like provide a library of like battle tested smart contracts that we can use in our own application to save ourselves from writing lots of code. So I mean, like we really wrote like 5 lines here or something like that nature for a complete ERC 20 token.
Okay. Yeah. Why are we creating migration?
Okay, so that's part of the way like truffle works. You can think of it like a database. So when we change states on the network, we want to be able to track that. So in essence, we'd be able to like think of our current state in on the network basically and track where we are, what we've deployed, and what we've changed. So that's the idea of migration, to like isolate changes, okay, and track them. That's the idea. We can't roll them back like in a database because like the blockchain is immutable, but that's the idea, to track state changes. So when we track state changes, we can like track deployment costs and know like what we deployed and what we haven't deployed. And that way like limit deployment costs and stuff like that.
Okay. Yeah. Okay, this is just a comment. Please help us to drop the documentation you are using. I guess the 3 documentation you open for Solidity, for Truffle, and for the Ethereum. So
Okay, so
that will be dropped in the resource channel.
exactly.
No. Okay. Okay, I guess I think you've attended to this. And there was a place where you did okay, the person says, why are we passing the to-do coin contract address directly in the constructor like you did with the owner? Sorry, why are we not? Sorry, yeah. Why are we not passing the to-do coin contract like you did to the owner? So I think you've addressed that. The
Yeah,
address in the owner.
I
Yeah,
think
you've
I
removed
did.
it. Yeah, yeah. I think that's when I saw the question. Yeah. Okay, why is constructor having an access modifier? It seems you also you took care of that.
Yeah.
Yeah.
So part of the boilerplate code that Truffle creates for us has that in mind. So it was like an older version of Solidity. So new changes, every constructor doesn't have a view modifier because every constructor is by default public.
Okay. Yeah. So there's a place. Sorry, go back to the code.
Okay. Is it?
The migration code. Sorry. Yeah, the first line of code that says TaskMaster is equals to artifact.require. So someone was saying, why can't we use // just like we're visiting a file?
Okay, that's also possible. That's also possible. But the idea is like this is going to be resolved by Truffle. So we can leave all of that like file finding and like path finding Truffle. The idea is Truffle, because we're using Truffle's project structure, we don't have to do that. Truffle is automatically going to go to the builds folder and find to do coin and stuff like that.
Yeah. Okay. Okay, I think you've also addressed this. Someone said, if I'm to write 1 million token in decimal as my fixed supply, how do I write it? Yeah, I think you've also addressed that, but you can,
Yeah.
like, revisit it.
So we have to like take into account the decimal places. So Solidity itself does not track decimal places. So we have to account for that. So basically we're going to like multiply it and like take into consideration the decimal places. So we'd have like a larger number that we now divide when on our front end basically to to give the effect of like the decimal places. So if we want to create like a million instead of like a billion, we change this from 9 to 6.
Oh, I guess that was why we got the 0. In the
Exactly,
first that was why
exactly.
we
I
got
think it was
the
0.0000 something. Yeah,
Okay, so basically the 10 times 10 raised to power 18 is taking care of our decimal place.
exactly. Because in the construct that we're inheriting from, which is ERC20, yep, we have decimals of 18 decimal places basically. So that's why you have to multiply it by 18. If you had like 5 decimal places, then this would become 5. So that's just the idea.
Okay, I think this is basically where we would have to stop end today's live section. And also, I think there is a video created by Emmanuel on how to create an ERC20 token. So I believe that will complement today's live section.
Yeah.
Am I right?
Yeah.
Yeah. Also, also a video will be coming out. To either today or tomorrow. On how to go about implementing the ABIs in the front end. We're so much sorry that we couldn't cover that today. Time did not permit us, so it will be taken care of. Yeah. So I think we've come to the end of today's section. Thank you everyone for following us.
Thank you.
We'll see you some other time.
Yep.
And we also thank our method, Emmanuel, for walking us through how to create this smart contracts and how to implement OpenZeppelin. Yeah, I think that is an added knowledge. Yeah, so thank you very much. Goodbye.
Thank you for
See you.
listening. Bye.